Let's look at another patch. In this case, it's kind of a sort of clicky organ kind of sound. I'll play it a little bit. Okay, so again, our algorithm is set to additive synthesis. We are applying a filter to this. Let's take a little bit of the global controls. I do have my volume turned down a fair bit, minus 24 dB. My tone is set to 73%. Voices are set to 8, so we can have chords. I also have Retrigger enabled. And so that's just, you can play around with this and see if it works. Turning on retriggering is a way that we can often save CPU. And so a note that's already playing will be retriggered when we play the note again, which is handy. I have interpolation turned off for right now, but I do have the anti-alias button activated. And so what this does is it helps minimize the high frequency distortion that can happen sometimes in synthesis. So you'll see we actually got some pretty high frequencies coming through in this patch. So so that's our basic global commands. So again, we've set this to additive synthesis. Let's take a look at each of the oscillators. So again, the combined sound is this. There's a lot going on. I'm actually going to turn off these and kind of introduce them one at a time. So here's actually operator D on its own. Here's operator C. Here's operator C on its own. So you can see that operator D and C together just use two sine waves. In this case, operator C is using a sine and operator D is using a sine 8-bit. And together they sound like this. In terms of the envelopes for both of these, for D, you can see we have an attack of 0 milliseconds, 3.58 second decay, 72.3 millisecond release, and an indefinite sustain. So you can see it's sustaining, that's just turned off, basically. So, okay. And then for C, almost the same, 0 millisecond attack, 36.7 second decay, and then a release of 453 milliseconds and no sustain there. So, all right, let's take a look. I'm going to turn these off. Now let's take a look at A and B. So these are really the sustain sounds we're hearing. Also note the coarse and fine tuning. So A is set to 1 for coarse. C is set to 1 for coarse and 0 to fine. And D is set to 2 for coarse and just a little bit of detuning, just set to 3. So just they're slightly detuned. So here's C on its own. And now adding D. So we've added those octaves. And you're probably noticing, if you're listening with headphones, there's some panning going on there, and that's what all of this stuff is here. So we have a little bit of random panning set. So this is set to 25. This ranges from 0 to 100. So a little bit of random panning. This area here, if we set this to 0, what it'll do is it won't do any kind of key panning, and this is panning. So this is actually our keyboard itself, the way our keyboard is set up. So if we set this to 100, so the higher values, when we set this to a higher value, low notes will be more to the left, and higher notes in the keyboard will be more to the right. This is sort of a typical sound that is used in for piano synth sounds. And then we're also setting our overall panning to just be a little bit to the left, so 12 to the left. And so you can play around with these. You don't even have to have this on. You can have all this just set to nothing, but it can add a little bit more liveliness to the sound. All right. So going back to our oscillators. So again, here's C and D. Now let me just look. Let's just turn on A and B. Or here's A. And here's just B. So these are the attack that we're hearing. So here they are together. So you can see, let's take a look at B here actually. So the envelope, the waveform is a SAW 6 for this. And our level is set to 7 dB. I forgot to look at this for these, right? So this was set to 0 dB. This one, the higher harmonic is for D is set a little bit lower. So it's minus 12 dB. For A and B, you can see A is set to 0 dB and B is set to minus 7 dB. So this is just coming down a little bit. And the values in terms of coarse and fine are both set to 1. And then we have a sawtooth 6th waveform. And then for the envelope, we have a 0 millisecond attack, so very quick attack, no attack really, just right away. 54.6 millisecond decay, 273 millisecond release, and a minus 67 dB sustain. So this is it's just a noise burst, just a very, very short, right? So very, very quick. And you'll notice for A, it's almost the same. So the envelope for A is almost the same. No attack, 0 millisecond attack, 22.8 millisecond decay, 1 millisecond release, and then minus 44 dB for the sustain. So there's that. Now notice that for this oscillator A, there's actually a user waveform. And so I wanted to show you this because what we can actually do is, sure, we can pick, a square wave here if we want. But let's go to user and create our own. So what we can do is we can just draw our own waveform. So what I'm going to do is I'm going to have a lot of the fundamental frequencies, all very, very high. And I'm going to have a little bit of some other frequencies here as well. In fact, let me just change. So something that looks relatively like this can work, and you can adjust it. If I actually want to hear it a little bit more, I'm going to bring up the envelope to hear what this actually sounds like. So you can see because the coarse setting is set to 8, right? It's a super, super high note. Here's 1. That's not what we want. We're going to set this up because we want this really high pitched. And if we bring this way down, the decay now, and you can adjust this and see what you like. If I combine A and B, right? And then we combine all of these together, we get a nice clicky organ kind of sound. So this is really the important aspect of additive synthesis, is having maybe a couple oscillators paired together making one kind of sound and a couple other oscillators. So these two, A and B, are really the attack of the initial attack, kind of giving this almost like a noise burst. And then C and D work together to kind of give us a kind of the fundamental sustain sound. So if you could imagine, this again is the attack, and then this is the sustain of the organ sound. So there is our first organ-like patch that we can build. Oh, needed to talk about the filter. In terms of the filter type, we're actually using a state variable filter. So that's this one right down here. I have it set to 24 and it's set to clean. My filter frequency, you can adjust this. In terms of the envelope, it's just full. It's just basically on. So 0 millisecond attack, 18 second decay, 50 millisecond release, 100% sustain. So it's just basically on all the time. But then in terms of the filter itself, we basically we're just selecting, this filter type instead of something, let's say, like a high pass. The subtlety is very, very, there's not a lot of difference, but you can hear it a little bit. So if you toggle back and forth between those. So without the filter, it's actually still pretty good. It's just a little bit nicer with the filter actually on. Kind of cuts some of those really, really high frequencies. Yeah, that's just a little bit more clean there. So there is that patch.